Okay, let's see how a velocity transformation works. So let's say that our person who is standing at xi actually decides to move. Let's just have them move at a constant velocity. They don't need to move at a constant velocity. Remember, the only things that need to be moving at constant velocity are our frames of reference. But just for the ease of them doing this example, let's just say it moves. He or she moves at constant velocity. Let's say that it's Susie. Okay, so Susie is moving to the right at some speed. Now be careful because we actually reserve the speed v to be the moving frame's velocity or speed. So we don't want to use v for Susie, so we actually use u. And this is just by this is just by convention. We use u for the speeds of objects inside the frames instead of v. So Susie starts at xi and has speed u. So the kinematics for Susie, she's moving at constant velocity. So in frame O, so we haven't done any transformation yet. In frame O, Susie's position is xi plus u times t, right? That's just the kinematic equation for constant velocity, where Susie's constant velocity is u to the right, xi plus ut. Okay, so let's go ahead and transform that. Remember, in the O prime, x prime is equal to xi plus ut minus vt. Right? We are just transforming the position variable. Whoops, never mind that. Whoops. Transforming the position variable, right? That actually what I wrote here was xi, but this is the position variable in the unprimed frame. We're transforming that position variable. So this what was a constant initially, which is why we call it xi, is now changing with respect to time. So we're just plugging in the new x for this. Okay, forget those things. Okay, there we go. So we take x and we plug it in here, and the transformation is this part, right? That's the transformation. It's transformed by minus vt. Okay, because the moving frame is moving with Susie, sort of like closer to Susie. Okay, so let's go ahead and take a derivative. Dx prime dt. Dx prime dt is equal to xi is a constant, so it's going to be u minus v. That's what we get when we take a derivative, u minus v. And what is x prime? Sorry, what is dx prime dt? That's just u prime, right? So therefore, the velocity transformation is u prime equals u minus v. This is what's called the velocity transformation. Still the Galilean transformation, velocity transformation. Often abbreviated velocity transform, or the other was the position transformation. And xform just is a xform is just means transform. X is short for trans. Okay, so u prime equals u minus v is the velocity transformation. All right, let's just make sure that works, right? Let's just say that Susie is walking down the road. Example, right? Susie is walking down the road at 5 meters per second. That's a fast walk. That's actually that's actually a run. That's all right. Susie is running at 5 meters per second, and let's just say that Frank is the actual moving frame of reference. So somebody's chasing after Susie because Frank wants to ask Susie on a date or whatever. Don't worry, he's not going to attack her or anything. He's just chasing after her. So this is Frank, and he is the moving frame of reference. So according to Frank, how fast is Susie moving? Oh, I didn't say. So let's say that Frank is chasing after her. He's not as fast as Susie. So Frank is chasing after her at 3 meters per second. So what is Susie? How fast is Susie getting away from Frank, right? How fast is Susie getting away from Frank? Well, Susie's velocity relative to Frank is u prime. And u prime equals u minus v. So Susie's velocity relative to Frank is 5 meters per second minus 3 meters per second. And it's equal to 2 meters per second. So Susie is still getting away from Frank at 2 meters per second, right? She's going 2 meters per second faster than Frank. What if Susie says, oh, Frank's coming after me. I want to stop and talk to him. And Susie turns around and goes towards Frank, right? Let's just say that Susie now changes so that U is minus 2 meters per second. She's going to walk back towards Frank, right? U is minus 2 meters per second. Susie is walking back towards Frank. U. In the stationary frame of reference. Frank, in the moving frame of reference, according to O prime, right? According to Frank's frame of reference, if he's still moving at plus 5 meters per second, then Susie's velocity relative to Frank, Susie's velocity relative to O prime is still U minus V, which is plus 5 meters per second minus 2 meters per second, right? We have to be careful with the signs, right? Because this sign, she has turned around. She's coming back towards Frank. So Susie is now moving relative to Frank at plus 7 meters per second. She's moving relative to Frank at 7 meters per second. Okay, hopefully you caught that error. Let's just say I did it on purpose. Frank's frame of reference, O prime, is moving in the plus x direction at speed v. Susie is moving in the minus x direction at speed u, or u prime, u relative to the unprime frame, u prime relative to the prime frame. So she should be moving in the negative direction, but that's a positive number. She is moving in the negative direction relative to both frames of reference. That's a positive number. So what did I do wrong? Oh, look, what I did wrong is that u is not 5 meters per second. Oops. V is not minus 2 meters per second. I just switched my two velocities. Super easy to do, right? U prime equals U minus V is correct, but that is minus 2 meters per second is U, and V minus V is plus 5 meters per second. So Susie's velocity relative to Frank is now minus 7 meters per second. Ah, that makes sense. We got to pay attention to direction. Make sure that comes out right? She's moving in the negative x direction relative to the moving frame of reference.